Good morning, everyone. My name is David Logsdon. I am the Executive Director of the Tech America Space Enterprise Council. And on behalf of the Tech America Space Enterprise Council, the George Marshall Institute, and the Coalition for Space Exploration, I want to welcome everyone to today's event focusing on Beyond Earth, removing barriers to deep space exploration. Welcome everybody watching live on NASA TV. To those in the audience and those watching on NASA TV, I want to point out we welcome your tweets today. The tweet hashtag is #DeepSpace. It is my distinct honor now to introduce the president of the George Marshall Institute, Mr. Jeff Keeter.
Thank you, David. And on behalf of the Marshall Institute, let me also extend our welcome and thanks to all of you for joining us today and watching at home, and my thanks to the panel and to our good friends at NASA for helping to support this discussion of deep space exploration. The Space Enterprise Council and the Marshall Institute have a long history of programs related to space topics, ranging from national security considerations to the economic benefits of space to space exploration. And this is the latest iteration of that series, and I invite you to learn more about that and to become part of that conversation as we continue going forward. These are exciting times for our space exploration program. We have moved beyond a set of technologies developed for a different set of missions and are now focused on sending men farther than we've ever gone before. And that requires new capabilities and new technologies to take us there. And so we discussed today the launch vehicles and the capsules and associated technologies to take men to deep space, but we would be bereft not to mention also that we are focused on developing new habitats for living in deep space, the in-space propulsion systems necessary to do missions while there, in situ research exploration, improved communication, and then the host of technologies needed to enable long-term human habitation in space, suits, robots, vehicles, and the like. These are indeed exciting technological times. It's my pleasure today, though, to introduce Mr. William Gerstenmaier, the Associate Administrator for Human Exploration and Operations at NASA. In this position, he provides strategic direction for all aspects of NASA's human exploration of space and cross-agency space support functions of space communications and launch vehicles. He provides the programmatic direction for the continued operation and utilization of the International Space Station, the development of the Space Launch System and the Orion spacecraft, and is providing strategic guidance and direction for commercial crew and cargo programs that provide logistics and crew transportation to the International Space Station. A long and distinguished career at NASA included activities overseeing the Shuttle and Mir program, the Space Shuttle, and the International Space Station. Mr. Gerstenmaier, the program is yours.
Okay. Thank you very much. It's my privilege to be here to moderate this great panel. And since I got to moderate, I got to kind of help choose the format. So I have slides and they don't have slides. So this is good. So I'll feel comfortable with slides, doing my normal NASA thing with slides, and then we'll have them without slides, and I get to ask them questions, and they don't have slides, so it'll even be better to see how all this works out. So first of all, I'll use the slides to kind of give us a little bit of a generic background on where we are and what's happening. If we can go to the next slide, since this doesn't seem to work.
Houston, we have a problem.
We have a problem here with the clicker. Oh, there we go. Oh, now we're back too many slides, so hang on a minute. Okay, so first of all, I think we ought to discuss a little bit why we're talking here today. And I believe strongly that exploration is critical to prosperity and human progress. And I think if you look back historically and you see what's happened, great nations that explore, they become world leaders and they move forward. And I believe it's really part of us, part of our heritage going forward, that exploration is absolutely critical to that prosperity and human progress. And you can think about that in your own examples, think about some history, and continue to move forward. I think we often ask, what's the value of human spaceflight? I think there's really three key things. One is knowledge. It's forcing us to learn new things, to apply technology in a different manner than we normally would. And that benefits us as a nation. That gives us new devices, new pieces of hardware that we can use to explore and go forward. But they also, leave behind, spin-off kind of things that can be used in other areas like computers. We're doing some things at the moon today with laser communication that will enable some laser communication activity here on the Earth. So again, I think the value of human spaceflight and exploration in general really helps us with pushing knowledge forward. I think it's clearly a piece of economic growth. There's a direct benefit or direct side of economic growth, and that's represented by the aerospace companies that work in this field that actually generate revenue, create jobs. But then I believe also we create an industry or an excitement for students and others that actually have benefits beyond that direct benefit of the companies actually doing work. So I think you see, again, economic growth both expand indirectly and also directly. And then lastly, the point is a better life. And I believe many of the things we're learning on the space station will have application to us here on the Earth, especially in the human health area. Many of the things that that occur to astronauts on space station, bone loss, immune system degradation, those kind of things, they'll give us a chance to explore those phenomena, those biological phenomena in a microgravity environment that will have real benefits to us here on the Earth. And then I think also just the inspiration piece that also has a drive that many of us in this field are here today because of what we saw in the Apollo era, what we saw in early spaceflight. That's motivated us to take those hard classes, to push through school, to end up with these degrees that are here. And that really provided a better life for all of us. I think, again, when we think about where we're going, it's really the destination is deep space. This graphic kind of shows, the space station in low Earth orbit. We're really pushing humans beyond low Earth orbit out into deep space. And I think you can think of it in three kind of areas. There's the area around the Earth, the Earth area. Then there's a proving ground, which is somewhere between low Earth orbit and then deep space. We're pretty active in the Earth area right now with the space station. It's been on orbit for 15 years, coming up here in a couple weeks. The proving ground is where we need to really understand how to operate in space in more of a routine manner. So just as we got to where we're comfortable now keeping a continuous human presence in low Earth orbit, we need to do the same thing in this proving ground region. And then when we really push distances as far as Mars, we really have to break that tie back to the planet. So we will become kind of Earth independent in my thinking as we move out to that region. So we see a natural progression from where we are today in low Earth orbit to this intermediate proving ground, out to the moon, asteroid kind of destinations, then eventually out to Mars. I think there's a lot of principles that are important for incrementally building capabilities. We have to recognize that there's a finite budget, and our activities have to be executable within the budget that we have available to us. So to think of something that's a grand plan that works great but isn't compatible with the budget, that doesn't work. I think we also need to look at technology from wherever we can get it and bring it in. We need to look at high technology readiness levels or things that are ready to go be applied. Again, I think we need to look at what industry is doing in some areas. Where industry has picked up modern manufacturing, we can flow that back into our processes to, again, lower our costs. So we need to take the best things that are out there and move forward. We need to we have to think about how we can use commercial space in this activity. We've seen things on space station with commercial cargo. We're going to pursue commercial crew transportation soon here. So how does that fit, and how can we use that moving forward? Again, if you take a look at these things, these are all things that I think are important for building capabilities. And then probably another one is all the hardware that we build and we put together really needs to feed forward into the next mission. So we're not building essentially a one-of-a-kind spacecraft or a one-of-a-kind system. We're building a system or a piece of hardware that can actually serve multiple missions, and that's an important aspect as we go forward. So we're not going to go optimize and perfect everything for one particular mission or one particular destination. We're going to build hardware that can really satisfy our future needs. So if you take a look at these 6 strategies, I think they're pretty important, and they kind of underpin what we're doing when we talk about the capability-driven framework. Again, we'll talk a little bit about space station. Space station is a tremendous test bed for us in low Earth orbit. it really is the first step in exploration. You know, sometimes it's talked about we can either have space station or we can have exploration. I think we really need to think of it as both. We really need space station to understand how systems perform in space, how the human performs in space. Can they make the 1-year duration kind of activities, 2-year durations? Are there any human limitations to what we need to go do? We have a lot of technology testbed kind of activities we can do on station with life support systems. We've got the docking system standard that was developed out of the space station program. That standard can then fit for other spacecraft going forward. It allows other nations to build to those same standards. We have rendezvous prox ops equipment that we can standardize and test out on space station. So again, if you look through all these things, space station is really a test bed or a proving ground for all the things we need in exploration. You know, I think we also need to think about how we transition low Earth orbit into the commercial market, or how does that fit? Can we use space station to show that, hey, there's benefit to a commercial company doing terrestrial research here on the Earth to doing research in space? And can we turn over a sense of low Earth orbit to the commercial sector by using space station as a testing or a proving ground? So I think space station plays a very critical role for us as we move forward into exploration. Now we'll talk about the Space Launch System. Again, a tremendous amount of progress is occurring. The developmental test firings have been completed by ATK. You can see the avionics getting set up on the right-hand side to begin avionics testing of the SLS rocket. And that'll be a major test to see that avionics come online, to see those computers working together and operating. You can see down in the lower left-hand corner one of the first barrel segments that got made. This is one of the segments that makes up the tank. It was made by the tool on your far right. That's a friction stir weld tool that essentially replaces 3 or 4 tools that used to build that in the external tank world. So we've learned from the external tank world of the shuttle how to be more efficient in manufacturing, and that allows us to build a rocket that moves forward. You see in the center some RS-25 testing that will start taking place next year. The inlet conditions for those engines are slightly different coming off the SLS than they were on the shuttle. We have 16 shuttle engines that will be used with SLS. We want to begin testing those engines at the inlet conditions, the oxidizer pressures and temperatures, and the hydrogen pressures and temperatures that go into that engine on the core stage as we move forward. So again, the takeaway here is there's real work moving forward. This is no longer a paper program. There is real massive hardware, real massive machines coming together using modern manufacturing that are getting ready to go build this SLS rocket for us. Again, if you take a look at the drawing release schedule, we're 70% complete. We're moving out, so then again, it's not just the physical hardware, but that hardware is being built to engineering specs and engineering design sitting behind it. So again, just tremendous progress in a very short amount of time of moving forward on this large SLS booster. Now we'll switch gears a little bit and look at the Orion multipurpose crew vehicle. Again, a tremendous amount of work's going on in the Orion world. We're getting ready for the expedition flight test number 1, where we'll look at the heat shield performance. That vehicle's down at the Kennedy Space Center in the upper left-hand corner. It just went under power on, which is a major activity for the capsule, where we bring power on to all the avionics systems. We see how all the 3 strings work together. We've done 9 parachute tests looking at a variety of conditions. We've looked at failed parachutes, failed reefing parachutes. We've done the water recovery test to make sure we can get the capsule back after EFT1. That's in the upper right-hand corner. The heat shield is essentially complete. It needs to undergo a little bit more testing up at Textron in Boston, and that's moving forward. And again, if you just take a look at all the hardware and systems that are coming together, there's tremendous progress being made forward on the Orion program heading up to the test flight next September. Again, I talked to you a little bit about the power on testing at KSC, a major milestone for any spacecraft as it goes forward. And then this is the expedition flight test program, where we essentially do 2 orbits around the Earth and re-enter at about 80% of the velocity that we'll come back from the moon with. The primary purpose of this test is to check out the heat shield and look at the heat shield performance. The heat shield is a major driver to the Orion weight, a major driver to the structure, so understanding how that heat shield actually performs is absolutely critical, and that's what this test will do next September. Again, if you take a look at where we are heading up to that flight, you can see the activities that have been completed, and they're checked off. I won't read these to you. You can see the activities are in front of us, but we're moving forward, and we're getting ready to head into the test flight next September. But again, tremendous real progress on the capsule and capsule design, and this is the capsule that will be used for the exploration missions later to come, and this is basically the capsule design, basically the avionics design. They'll be used for crew flights in the future. So this is not a one-off demonstration. This is the actual beginning testing of the capsule to gain experience with it. Now we're talking a little bit now about the exploration mission number 1. We've decided recently to take that to a distant retrograde orbit. That's essentially an orbit around the moon, opposite the direction that the moon travels around the Earth. That's a stable orbit. It's about 75,000 kilometers off the surface of the moon. This is an intriguing orbit for us because we can look at this orbit as essentially an orbit that if we can put an object in that orbit, it can stay there for up to 100 years without any attitude adjustments or any corrections. So it plays an interesting role. We're going to talk about an asteroid redirect mission in a couple charts. You can essentially take the asteroid and put it into this distant retrograde orbit. It stays there for an extended period of time, and it can be then visited by crews on the Orion capsule. So this is a chance for us to push out into that inner region. So if you remember that first chart where I showed you low Earth orbit, and I talked about that as where we are today, and then I talked about the proving ground, which was the second piece. This is really the beginning step of that proving ground. We're going to take this capsule into this region around the moon and see how we can actually use lunar gravity to get into this orbit, use lunar gravity to get out of this orbit, and then return back to the Earth. And this is about a 21-day mission. So this is the beginnings of us learning to operate in cislunar space, to use the gravity of the moon to go to various destinations and various distances in the solar system. Again, this is the asteroid redirect mission. It starts with the launch of the robotic spacecraft. The robotic spacecraft goes out, captures an asteroid on the order of 5 or so meters in diameter, about 500 metric tons. It then returns that asteroid through, as I just described to you, it swings past the Earth, swings past the moon, does a lunar gravity assist, ends up in this distant retrograde orbit, and then Orion can go visit that orbit, and we will do a spacewalk out of Orion because Orion has capabilities for EVAs internal to it, so we can do that without any modifications. So again, when we talk about hardware feeding forward and supporting multiple missions, Orion clearly does that. Orion has the ability to go to this distant retrograde orbit, it has the ability to support an EVA, and it has the ability to support crew for up to 21 or 22 days, which is what this mission would require. So again, I think if you look a little bit at the asteroid mission, and I won't read these words to you, but you can take these with you to go look at. I see this asteroid redirect mission not as a mission in itself. It's not a one-time event. It actually is building capabilities that we need in terms of systems to go into deep space, to go distances as far as Mars. You can read the systems capabilities are there. We also have some operational capabilities and demonstrations we need to go do. So this mission isn't a mission in a sense as much as it is a proving ground or a way to test critical components that we're going to need to go do Mars-class missions. This also allows us to have the capability to do lunar-type activities. So if we want to do something in the vicinity of the moon, or an international partner wants to do something on the moon, we will be there in a distant retrograde orbit. We can go into low lunar orbit from that position. We can go to Lagrangian points. We can operate around the vicinity of the moon. So again, don't think of this as one mission. This is really a way we can hone skills, do proving ground kind of activities to get ready to go support multiple missions as we go forward. And then the last point is, again, back to the kind of the benefits chart. These are all the partners and suppliers across America that are participating in SLS and Orion. A pretty amazing swath of companies throughout the country. Very, very dynamic and very beneficial overall from an economic standpoint. And then again, I think if I tried to summarize in just a few short sentences or thoughts what we're really doing here. You know, we see this as a deeper vision. We're really pushing into deep space. We see this as a bolder mission. This is not easy, breaking the tie with the home planet, and we're going to do it incrementally, one step at a time. And I would suggest EFT1 next year in 2014 is that first step. So we're moving forward. I think it's clearly a pretty cool vision, a pretty nice mission, and we're really going to do it incrementally as I just described on the charts. So with that, I'm done with kind of the opening scene setter stuff, and now we'll turn it over to this great panel here with some questions. All right, so I guess we'll start, oops, oh, guess I can't bend over. So we'll start with Charlie. You know, what is the capabilities approach, and why do you think we should start there?
Well, first off, thanks for organizing the panel here today, and to the hosts that have had us here this morning. This is a great opportunity. I think I can speak for all of us. We feel really privileged to be part of the next big leap in exploration. When you think about capabilities based, in fact, I believe we've been developing capabilities for human spaceflight since the beginning of human spaceflight. If you look at what Mercury was about, could we get an astronaut to orbit and return him safely? Just the launch and the recovery. Once we figured that out, the next capability was, can we exploit space for productive means? And Gemini brought us the ability to do rendezvous and docking, to do spacewalks, things that we'd need on the surface of the moon, with the goal of Apollo to be able to focus on an end point of getting the first crew to the moon and return them safely. Albeit with a very short duration capability, because that was at the time the technologies that we could actually execute. Following on Apollo, the thought was with shuttle was, let's go exploit space more routinely, more frequently, for longer periods of time. Let's do research from the payload bay. Let's deploy telescopes. Let's deploy science. And then let's deploy a space station. So space station and shuttle were about permanent living off the planet. When you think about that capabilities evolution of what we've been able to do, the next logical step is permanent capabilities of life on another celestial body. And so what we want to do with these capabilities now is, as you pointed out, we want to make sure that we evolve this vehicle according to the mission demands. There are a couple of ways you could develop a system to put crew on Mars. You could build the end state 130-ton vehicle, as we're all targeting to do. But we have a lot of missions along the way to develop further human capabilities, as you pointed out with the asteroid retrieval mission, being able to dock with a vehicle that is in a deep retrograde orbit to maneuver in proximity to an asteroid, which is a much smaller mass, being able to perform those rendezvous and station keeping operations, to be able to support human life beyond the protection of low Earth orbit and the Van Allen belts, the deep space radiation exposure that we still have to mitigate. We're learning on space station how to maintain the health of the crew. Now we want to exploit that going deeper. So as you look at the roadmap to Mars, there are a number of things that we're going to do along the way that don't demand us to build a 130-ton vehicle on day one, but we grow into it and evolve along with the mission. So your missions that you show for 2017, EM1, is the 70 growing to 105-ton capability, and then as we go deeper and deeper into space, eventually putting crew on the surface of Mars, we'll need that 130-ton capability. So I think it's a wise approach to build as we go. And I sure like the reference you make to inspiration. When I think of this mission, I think we are within reach of putting crew on the surface of Mars in our lifetime, the folks sitting in this room. And I remember the photo from Apollo with the Earthrise on Christmas morning. And think about being the first crew on Mars, where tonight go out and try to find Mars in the night sky, be that first crew on Mars to try to find Earth in the night sky. And it's a pretty inspirational thought.
Thanks, Charlie. And I know you have a lot of experience in the international world, so is there any role in this activity for the international
There
partners?
absolutely is. As we just discussed, the capabilities evolving for the launch vehicle are a piece of the total system that we'll need to explore. But we need deep space transportation propulsion. We need habitats that can support the crew for long duration in space. We need landers, we need robotic systems. And if you look at what we did on Space Station, each of the partners came with a talent and a capability that combined to create today's space station. We stepped out there and gave the Russians the responsibility for guidance, nav, and control for the main habitat living command post for the crew. We brought on the U.S. laboratory module, but also the solar arrays and the ability to maintain control of the attitude of the station. The Japanese brought their own laboratory module, as did the Europeans. The Canadians brought robotics. Think of that model and how successful it's been. We'll need to do the same thing with exploration, where our partners will bring those capabilities I mentioned we're going to need: landers, habitats for deep space, the ability to protect crew from radiation as we go out beyond and further into space. So each of them can contribute and build upon the infrastructure of the SLS and the Orion, which supports getting all of that capability out to space. So.
Thanks. John, let's talk a little bit about the Heavy Lift Launch Vehicle, SLS, and why is SLS critical to this activity?
Yeah, thanks, Bill. Let me add my thanks to Charlie's for the folks that organized this. The four of us have been working really closely together, not only to ensure the SLS Orion programs are executed well, but also to ensure that there's a understanding and advocacy for where we're going. And so this is a great opportunity to do that. The first thing I'd like to mention, Bill, is so I had a chance to go to Baikonur for the launch last week, and it was my first trip over there. And it was fascinating to see the system the Russians have in place and how disciplined that is, how steeped in tradition it is. But I couldn't help but think while I was there that here I was halfway around the world in one of two spots where humans could be launched into space, and neither of those two is the United States at the moment. And so I think it's just absolutely critical that we move forward with the SLS and Orion programs to recapture that leadership that is rightfully ours, I think, moving forward. If we don't pick up that mantle, there are other countries in the world that are ready to, for the national prestige, for the technology developments that will come out of that and bolster their economies, and for the inspiration for their children to study math and science. So just absolutely important that we move ahead with these programs and cause those things to happen. So why is a heavy lift vehicle important? The first thing I think of is, as we move on to explore in deep space, we're going to build some sort of complexes in near-Earth orbit to take on those journeys. Certainly not as big as station, but requiring some of the same kind of effort to do that as was done on station. Station took over 40 assembly missions and about 12 years to build on orbit. If we had had a larger launch vehicle capable of carrying bigger volumes and more mass, we could have done that with significantly fewer flights. That would have reduced the cost, would have shortened the time it took to do it, and it would have reduced the risk relative to the number of missions that you have to string together to make that happen. So if we're going to be successful going forward, having a vehicle that can carry large amounts of mass into low Earth orbit is important to make that happen. Just some examples to think of. Imagine if the James Webb Telescope was able to be designed to fit in a larger volume and launched into orbit. It wouldn't have to have the same amount of on-orbit kind of erection that it has today. And so you can imagine that it would have been simpler and less costly to build a mechanism like that. If you think about going to Europa, for example, the additional thrust of an SLS could get us there in 2 years versus what's imagined as a 10-year mission with the rockets that exist today. So a significant change in the capability. I think it's interesting, there's an independent group that's looking at exploration into deep space. And that group initially started out with a baseline of using smaller launch vehicles, but as they went through their study, quickly came to a conclusion that a large launch vehicle was really the efficient and affordable way to do a mission into deep space. And they kind of validated the path that NASA's on. I think it's also important to talk about SLS as an affordable vehicle. Charlie mentioned, and Mr. Gerstenmaier mentioned, reuse of shuttle main engines, of boosters, and all that reduces the development cost that's necessary, takes risk out of the program, adds to affordability. Certainly as a team, we are tightly managing the execution of these programs, and SLS at the moment is about 5 months ahead of schedule and below budget in its development. And that's incredible for a system of this complexity. And so keeping that focus is important to keeping it affordable. And then finally, if you look at the cost per pound that we're going to be able to take into low Earth orbit, it's right in line with the cost per pound that we're seeing on the CRS contracts today and other commercially available rockets that are taking payloads into space. And then that's not considering the cost benefits you get out of, as I mentioned, being able to do these missions with fewer flights, larger pieces that require less integration, and taking the risk out of them. So hey, we're right on the edge of being able to do this, as Charlie mentioned. And so we have just got to rally around putting the advocacy in place to push SLS and Orion through the development phases, get that capability in place, reassume our rightful place as the leader of the international community that's doing exploration, and continuing on. And it's just exciting to be a part of the team doing that, and I can tell you that the folks working on it are just really stoked, especially the younger folks, to be working on the next generation of exploration beyond Earth here.
If I could brag on John just a little bit, the folks here are used to me doing this. I always chime in. If you haven't been to the Michoud facility and you happen to get down to New Orleans for some trip that you're on, especially those of you in the press, please take advantage of seeing what they've done there. It's totally modernized, and as we've alluded to here, we are leveraging the past hardware from Space Shuttle and previous programs, but this isn't your grandfather's Space Shuttle equipment. This is brand new modernized equipment at the Michoud Assembly Facility. It's resulting in much more capability and reliability at much less cost. Same for the booster. We're doing the entire booster that was done on Shuttle with a fifth segment, 25% increase in capability with 1/4 the staffing that we used to have the Space Shuttle boosters built. So these are capabilities that are evolving with much greater reliability and affordability at the same time. And the folks at Boeing are doing a really tremendous job with the core stage down there, MAF.
All right, thanks. Again, I think, as John said, that it's nice to get a little independent confirmation that the laws of physics are still true. And there is real advantages of this big rocket to go do the assembly. So as John tried to describe to you for the International Space Station, how it could have been done much simpler, it's neat when we see somebody else coming in to take a look at a Mars class mission, and they come back and they say, hey, we really need that size rocket to pull this mission off. So it's really good to see that confirmation that physics still holds, and there is some real advantages to what we're doing. And the progress at MAF is also tremendous to go look at. Hey, Julie, why don't we talk a little bit about the challenges to get to Mars?
Okay, again, thank you for putting this event on and having us here to be able to talk about such an exciting subject. Personally, I'm just thrilled to be a part of it. I've been into science and space since I was a little kid, reading both science fiction as well as science, and now we're getting to see the marriage of the two coming together with going to Mars. And it really can happen in our lifetime, in our generation. We have the tools now to do it. It won't be easy, but it is just amazing to see the kind of things that we'll be able to, the problems we'll be able to solve and the progress we'll be able to make. And so if you think about going to Mars, that with people, that'll be harder than anything we've ever done, okay? It's, instead of being a few hundred miles away, we're gonna be 35, millions of miles away. And it takes us, as opposed to a few days, like when we did lunar missions, or when we take a few hours when we take people up, we're gonna be gone for years, okay? And then, assuming we ever wanna land, which is, I think what our goal is, we're gonna have to live there. We're gonna have to live in a place we've never been. We're gonna have to live and have all the living things, the tools, the shelters, et cetera, in an environment we know something about, but we don't know everything about. And so, I look at it as I hike a lot, and I'm looking at this as a big expedition, and when you set out on an expedition, we're going somewhere no one's ever been. We've sent some robotics, but no person has ever been. We're going to be in an environment that we don't know everything about it. We're to be gone longer. And somehow or another, we got to bring everything with us to be able to deal with whatever's going to come our way. Because I guarantee you, we're going to find out stuff. And we'll be real smart about this, how we do things, but we're going to find out stuff we've never known. So we got to be prepared for that. So instead of, when we put the laboratory on Mars, a little while ago, and we were all terrified about landing a ton, a small car, or small SUV on the surface, we're going to be landing at least 40 tons of stuff. We're going to be landing the equivalent of houses, multiple houses on the surface. And so those are the type of, magnitudes of things that we have to deal with. And, it's really hard to get off the Earth, okay? It just takes so much capability, and the only practical way to do this is with a large rocket, and that large rocket's an enabler. As we think about how we're going to do this, we got to do it in a stepwise fashion. We aren't just going to go, pile everything on the rocket and head there tomorrow. We've got to go and have a thoughtful way to deal with solving some of the problems or some of the challenges that we have, such as how are people going to deal with living in space a long time? How are we going to, position all these things to get them there at the right time? And so you think about it, we have transportation, you have life support, and then you have landing and living on the surface of Mars. And so from a transportation standpoint, we've talked a little bit about SLS. Well, having a big rocket is going to make this possible because you have a lot to bring up there. That 40 tons doesn't come easy, and that's, if you were to use it with our current expendable size rockets, we'd be launching all the time to just get stuff up there. I'm not sure it would be very practical. So that's critical. And then you think about it, we're taking people. Robotics are absolutely critical for us being able to do this, but when you take people, it kind of ratchets the game up even further. We always design our rockets to be reliable for every mission, but when you have people on there, that's a whole nother ball game, in terms of how you think about it, how you feel about it. As we do that, we're going to build off some of the systems we have experience with, because we're going to be asking these systems to do even more. If we were to say, okay, we're going to go develop the brand new rocket propulsion that's, Six Sigma to the best performance, it's like, okay, we could do that, but we'd be taking added risk. And so taking an approach where we build off what we know and incrementally improve it, is the right way from a risk managed way to get people there. And we're doing that by reusing RS-25s and then evolving those to be able to solve this mission. We also got to think about, how do we come back? How do we get people into the orbit? How do we land? And that's going to be quite a number of different transportation systems that we're going to have to put together. And as we mentioned earlier, we will be relying on partners to do some of this. This is a big venture. It's not like one single company is going to do this. This will be a world type effort, and take the capabilities, both financial as well as people to do that. In terms of the life support, think about, we're going to have people, in space a long time, on the surface of the planet, and then coming back. And we're talking years. We've learned a lot being with station. We talked about some of the earlier precursor missions about being able to position things in space. And those things will allow us to learn more about that environment and get us ready, for taking that next big step. And then the landing side of it, we think back on when MSL went down, and believe me, our propulsion was bringing it down a lot of the way, so we were thinking about that pretty hard. Now we're going to be landing a lot more stuff, and we're going to have people. And so, perfecting the systems to do that are going to be critical, because we're not going to go and view the goal, and then we don't want to have any doubt that we can actually get there. So, it's a lot of things, and you think about it and say, oh my, that's something that is the stuff of science fiction, but it's not. We really have learned a lot in space over the last 50 years. We're learning and putting more things together, and that basic infrastructure, and that's what we're talking about with the capabilities thing. It's really an infrastructure. We're putting in place the infrastructure so we can be spacefarers. And that is really what it's all about. And you don't just say, I'm going to go do it and do that tomorrow. You got to think about it, plan it. There'll be a number of different missions and pieces that go together. But I think the type of accomplishments we've had to date, the things we're doing today, and the things we're going to do here very near in the future show that we're ready to do that. And, I think as a set of partners, as a set of capabilities that we have, with NASA leading the way to do something that's never been done. I think we're ready to go do that. So I'm pretty excited and want to be part of that, making science fiction a reality.
That's really good. I mean, you articulated extremely well all the challenges. So with those challenges, there must be some benefits, right? So
yeah.
So now you got to kind of come the other way, right?
Well, there's, solving, I mean, talk about it from, I'm a glasses, half empty, so I always look at, okay, what's it going to take to do that? But by doing that, I think you accomplish a lot more. And we're going to face a lot of things and solve a lot of, things that are based on physics in doing this. We'll increase the scientific knowledge of our country. We, again, will reestablish a leadership capability. I mean, we'll be, every time you go into space, you go do something different. We learn things. We bring back and develop products. We develop capabilities we never dreamed of. And so that'll be a part of it. Space economically, the space business is a very large business for the U.S. and worldwide, and it's growing. Okay, this will create, not just some, create jobs for the people that are in the industry, but it'll create things that none of us can even imagine right now. And then again, it'll, further where humankind goes. I mean, it's, I think we're born with that, desire to move forward, to improve life for our children, to learn new things. And this will be, maybe it's not the ultimate, but it's certainly a big step along that way.
Thanks, Julie. Jim, let's talk a little bit about sustainability. How do we show that these programs are sustainable, or are they sustainable?
Sustainability, I think, is really at the heart of the SLS and Orion program. Basically, when we talk about Orion, it's the multi-purpose crew vehicle. So both SLS and Orion are designed to really do more than one mission, not to be optimized for just one, but to be spread out among many missions. John talked about being able to launch not only Orion, but to be able to launch large payloads. I'm always amazed at the fact, as John said, that it would have taken almost 3 dozen shuttle launches to put up the International Space Station, and SLS could have done it in only 2. That's a factor of 20 improvement. And not just in the number of launches, but think about the time. You can take something that took a decade and compress it into 2 or just 2 launches. Same thing's true with exploring the outer planets with SLS. Science payloads that go out can be done in half the time. So rather than a researcher waiting for a decade or more to get his data back, or when you think about the entire mission, maybe 20 years from the time you design a mission today until the time you get the data back, if you can cut that time in half, the amount of research that we can do is just phenomenally increased. Secondly, Orion is the multi-purpose crew vehicle. So not only going to cislunar space, but also back to potentially asteroids, and then to the moons of Mars, and then to Mars is a vehicle that allows us to explore our solar system without having to have different systems designed for each one of those missions. So the fundamental thing here is to have many missions that you can spread the cost over, and that leads us to sustainability. The second thing is both at all of our companies, modern manufacturing techniques are really speeding up the production process and bringing down cost. We've already talked about down at MAF where we're putting in automated friction stir welding systems. The same thing's true where we're building Orion. We're using a lot of what we call the digital tapestry, where we go directly from design to manufacturing without intermediate steps along the way. And using things like additive manufacturing, what many people call printing parts today, is really accelerating some of these processes even more than some of us dreamed of just a few years ago. Some of our planetary missions are actually flying printed parts today, and we're seeing a phenomenal increase, sometimes a factor of 6 to 10 in the cycle time that it takes to build these parts, and those are being folded into our manufacturing processes as we're going forward. Another thing we're doing is, as we talked about all of our robot explorers that are kind of going the way and before humans go and actually understanding the environment, I was really struck by some of the science that just came back from the Kepler mission. In Kepler, I'm sure that you saw in the press that we now estimate that over 10 billion planets in our galaxy are within what's called the habitable zone, where liquid water is able to exist on or near the surface of the planet. 10 billion planets. People were excited when they found out that perhaps the closest one was only 12 light years away. Now, 12 years a light year away, to give you some example, the Voyagers would take about 250,000 years to get there. But I think we forget that the nearest planet in the habitable zone is actually only about 35 million miles away, and that happens to be Mars. We know now that from the rovers and robotic spacecraft that we sent to Mars, that Mars at one time was very wet, and in fact, recent data coming back from Curiosity says that within a cubic meter or so of Martian soil, there's about half a pint of water trapped in that soil. And as you go deeper in the Martian surface, there's probably a place at a few thousand feet that there's actually even liquid water today. So we have a planet that's not very far away, that's explorable by humans, and that's pretty exciting. So we're going to learn about these planets that are probably spread all over our galaxy, and the closest one to Earth is not 12 light years away, it's a 9-month journey, and that's what Orion is ultimately focused on. That's our ultimate destination with Orion and the SLS system, and that is really, really exciting to think about, that within our lifetime we can actually explore one of these planets that now we know is pretty common throughout the galaxy, and even more so throughout the universe. But to do that, a sustainable program means that we're able to go with the funding that we have, and basically by bringing our international partners in to do the pieces that they want to do, I think that we can do this in a period that will be sustainable. And part of that sustainability is having launch rates that are frequent for two reasons. One, that helps us in not only with human exploration, but also with many of the robotic programs that we want to do. And secondly, as Julie talked about, it allows us to develop the capabilities to do this in an incremental way, and not in one huge mission, but in many missions along the way. That exploration opens up new opportunities, not only for us, but for our international partners who are expressing great desire to come along beside us and be part of this great journey of exploration.
Wow, that's pretty interesting to think about another planet in the habitable zone, and it's definitely worth exploring. So kind of interesting ways to think about this and to frame it in light and tie into science. You know, I talked a little bit about some of the Orion milestones that are out there. Are there any that you'd like to highlight or add?
Well, one of the things on the Orion that I'm really excited about is we just had power up. And power up on a spacecraft is really an exciting time, because that's when you're really starting to get into the launch flow. So we're now within a year of launch. It's kind of interesting to me that we're launching MAVEN Monday of next week, and then we immediately are looking at being in launch flow for Orion. So we just powered Orion up. All the avionics and power conditioning units and everything came up and are running just fine. We're running the software that we'll actually fly with. The next big event is the delivery of the heat shield. This is up at Textron right now, getting its final testing done. This is the heat shield that will protect us as we re-enter the Earth's atmosphere. As Gerst said earlier, will be about 80% of the velocity of coming back from the moon. We want to see how this heat shield performs. It'll be delivered to the Cape in just a few months and mated up with the Orion spacecraft. So we're really excited about seeing the heat shield come in together. Right now we're putting all of the external equipment on, all the boxes and avionics and things that tubing welding and everything is going on right now with some of the automated tube welding processes that we have. And the flow down at the ONC building in the Cape is just phenomenal to watch. And so we're just getting into the launch flow and ready to move forward to our very first test flight, which is now within a year from today.
Wow. Pretty exciting times. Again, when you saw in the images earlier, lots of exciting activities are occurring. What we'll do is I'll kind of talk a little wrap up here, and then we'll open it up to questions from the audience and see if there's any questions from folks. If I could have my next slide on the screen, please. Somehow this is going to happen. So this is, we've talked a little bit about many aspects and challenges of deep space exploration, and I happened to get this image here, and you're seeing here an actual image taken from NASA's Cassini spacecraft, and this image is going to be released today, and you're seeing it for the first time here at the museum. Cassini was able to capture 323 images in 4 hours, and this image you're looking at on the screen is a mosaic that uses 141 of those images. If you look on there, you can see what we mean by kind of deep space in a way. There's our home planet, the Earth. You can also see Mars, and you can see Venus. And so when you look at this perspective, maybe it makes you think a little bit about what we're talking about here. We're building systems, hardware, putting capabilities in place that are going to allow us to go move humans into these various regions of space. So when we kind of idly talk about 9 months to Mars, you could kind of see the dimensions there. The moon is kind of lost in this image. Space station is almost in the Earth's atmosphere, so you can't even see it in this image. So if you look at this, where we are today, we've really not gone very far into space with humans. And it's really our job, and the systems and the hardware we're putting together is going to enable us to go to these kind of regions. And I think this is a pretty compelling image when you look at this and you think about it in those lights. So this should challenge us and think about what's in front of us and get us excited about how we're going to use these capabilities and hardware we're putting together to go do some pretty exciting things coming in the future. And I ultimately believe what we learn here will have direct application and benefit back to us here on the Earth. So pretty exciting times. So with that, I think we'll bring our moderator on and open it up to some questions.
Okay, we'll take some questions from the media. I know a lot of you probably have questions as well, but given our time restrictions, we are going to entertain questions from the media here on the floor and on the bridge line only. To our media guests, both here in the studio and on the bridge line, I want to thank you for being here. This is an important American story, and we couldn't tell it without your help. So thank you for being here and for all your support. I think I'm going to take a few here, then we're going to go to the bridge line, if you will, just for the record, and so our panelists know who you are. Wait for the mic when I call on you, and then when you get it, state your name and affiliation for the record. Let's start with Dan Leone, front row.
Hey everybody, Dan Leone with Space News. Once upon a time in Washington, D.C., the president was enthusiastic about going to Mars, and a Congress where NASA enjoyed broad bipartisan support was happy to fund the initiatives, and that was called Constellation, and we didn't go. And now, although the current administration is less direct about the desire to go to Mars immediately, the situation has not changed all that much, and yet now we have a program where we haven't got a capability that would allow a human being to land on an extraterrestrial surface yet, and we haven't gotten a strong signaling of an international commitment to make the total picture happen. And on top of that, there are still budget troubles, evidenced by the slide, Bill, that you had, that a slight increase would be very helpful for these capabilities that you are building. What is different this time? What makes SLS and Orion the capabilities that will persevere and eventually be part of a Mars campaign, and how do we afford it?
Well, I was struck by a couple of things that you said, and we'll probably have many different answers to the question, but one of the questions, one of the things that you posed was that our international partners aren't ready to kind of step up and join this, and I really don't believe that's true for two reasons. So I'll give you two concrete examples. I was in China with several members on the panel here at the International Astronomical Federation and the IEC, and at that conference, many of our international partners talked about roles that they want and desire to play in space exploration. And in fact, there's a conference, head of agencies, actually coming up in January. So there's an enormous amount of interest in doing that. I'd also point to more than interest, as you I'm sure are aware, ESA is actually providing the service module for Orion. So this is a piece of hardware that's already in design. As a matter of fact, shortly after the first of the year, we'll have the PDR, the preliminary design review for the Orion service module being built by Astrium in Bremen for the exploration missions that are coming up. So our international partners are not only excited about the possibility of being part of it, they are part of it today. And that's one of the things that's making this affordable and sustainable moving forward.
Yeah, I'd certainly agree with Jim that there's a strong international interest in being a part of this grand adventure. And it's our role, as I said earlier, I think, to kind of step out and map out that path and lead the way. I think the budget challenges are precisely why we're focused on developing capabilities first, so that we can take this stepwise. And once those capabilities are in place, then we can develop the next set of capabilities that are going to be necessary to continue this journey. Stability with that funding over a long period of time, I think, is as important as the level of funding going forward so that we can do that.
And I think in the interim, we've also all seen some tremendous improvements in how we build this system for NASA. And I got to give kudos to the NASA integration team, the program offices. They have really stepped up the ability of us as a contractor and NASA team to deliver more cost effectively. And it's true, I'm building a booster with 1/4 the staffing it used to take to build it for shuttle. These are lessons learned from lots of years of this industry NASA team working together. So the sustainability capabilities are being put in place as well as the exploration capabilities. So we feel pretty confident about the ability to deliver.
And again, I think if you go back to one of my slides where I showed the 6 things that we think are important in this idea, those 6 things came about basically, how do we keep this program moving forward in a real and measurable way where we're making real progress along the way, but ultimately we're putting in place hardware and capabilities that will allow us to go do the Mars-class mission. If we laid out a path directly to Mars and we laid out all the vehicles and all the testing and all the work to get there, then you end up with a fairly long period of time with a lot of funding that goes into that activity that says this program is something maybe we don't want to go do. But if I put it in incremental pieces where we're making real objectives going forward, it makes sense. If you look at this asteroid redirect mission, we basically had SLS and Orion. Some folks looked at bringing this asteroid back into the vicinity of the moon. We were able to add it in with essentially no additions to either SLS or Orion. Orion had the basic capability to support the EVA. The SLS, even in the early configurations with a 70 metric ton capability, it had the ability to get to the distant retrograde orbit around the moon in service. So you're seeing evidence right there. We put components together that weren't point focused for one particular mission. They were generic in nature, and then when a new desire comes along to go do something, we can do a mission like the asteroid redirect mission in a fairly short period of time. Then we're going to leverage off of that mission to gain more skills, to put more things in our toolbox that allow us to keep pushing further into space. So rather than picking a date and a destination and then have that get changed somewhere along the way, we're building essentially an infrastructure that supports and allows us to move forward. Julie said it extremely well. She said, we're essentially building the tools that make us a spacefaring nation. So instead of being a nation that builds single-purpose tools to do one objective, we are generically putting together tools that make us a spacefaring nation that allow us to continue to push humans into deep space. And that's why this is different than what we've done before.
I think we also looked at how do we, as opposed to just always looking at the hardware and the technical, which is the really fun part about it, we've looked hard at the business systems, the business approaches, and the partnerships and how to do that. And that's critical. I mean, we're not living in the world we lived in, 50 years ago. We have challenges that we face as a country. The world faces challenges, but we can't sacrifice that desire to explore, that desire to advance humankind. And we've just had to look at it from a different perspective. And I think I can speak for everybody on the panel here. We've we've ratcheted this thing pretty hard, from how do you approach it business-wise, contract-wise, how do you look at doing things differently so that you can live with, flat budgets, you can live with a fixed amount of funding and still be able to do this. And it really was taken, we had to all look at the problem a little bit differently, but I think, I've watched everybody do that, we're all doing it a little bit different way, but now that we're all there, I think we're humming along pretty fast.
Thank you. Thank you, Tarek Malik with Space.com. And my question has to do with the larger reach out into deep space. There was a lot of discussion here about the stepping stones for Orion, for SLS, and the president was fairly specific that he was really looking for an asteroid mission by 2025, a Mars mission in the 2030s. And if you can push out those stepping stones, where would you see those milestones having to slot in for both these programs and then the commercial partnerships, the international partnerships? Because I would assume those types of programs would have to come in concurrently with SLS and Orion. Thanks.
I think a key aspect of, so this thing is, the plan that's laid out is complementary. A key aspect is continuing to operate stations so we can learn the things that we need to learn there, but doing that in an affordable way so that there's funding left over in NASA's budget to continue development of Orion and SLS so that we can do deep space exploration. So that's how commercial fits in there. The job of going to low Earth orbit is fairly well understood. We've been doing that since we sent John Glenn up there 50 or so years ago. And so the unknowns are less, the risk is less, and it's a good fit for having commercial do that and lowering the cost. And then having the NASA-led programs that are focused on the really challenging parts of deep space exploration, continue that. So I'm not sure I got the question, but that complementary relationship is very important in the overall scheme of what's going on.
Okay, let's go to ABC News. Gina.
Gina Sinceri, ABC News for Charlie. Charlie, as an astronaut, would you have volunteered for a mission like this, and what do you see the psychological challenges being for a long-term mission for an astronaut on? And you're going to have several people who are going to be up there, really good friends, for a long time if this happens.
Very true. I certainly would chomp at the bit to be able to have a mission like this. I remember when I joined the astronaut program, we were basically a US-only program doing orbit missions on shuttle. Station was in our sights, but we were trying to design it still. And we all were challenged just to do 10 days to low Earth orbit, and we were extremely challenged with the prospects of space station. Bringing on our Russian partners was a huge deal for us to leverage what they had and that we had that we each other didn't have. That was a hugely complementary capability to put those two programs together and bring on the other international partners. We've learned a lot about how to live long duration on space station, but the next challenges are going to be how do we protect the crew from radiation? How do they enable themselves to be able to repair and maintain their systems without immediate help from Earth? Orbit is a couple hours return time in a dire situation, and yet we're going to have crews out there way beyond the capability to communicate immediately. 20 minutes of time to transfer a message by radio. So the crew's going to have to learn to manage systems and make sure that they can sustain themselves. And when I was chief of the astronaut office, we used to think about starting the space station challenge. And we studied things like Shackleton's voyages to Antarctica and what he had to go through and the ability to sustain crews for a long period of time away from help. And so that's what we're doing now by going into deep space, is taking on those challenges, and using space station, as Bill said, is extremely important because it's a laboratory for all those challenges, but it's close to proximity to Earth should things go wrong. Once we step out away, we're putting the crews on their own to a large degree to be able to manage their lives and repair things along the way to sustain themselves.
Okay, we'll take another question here from the floor, then we're going to go to the bridge, and then we'll return for some additional questions. Paul?
Yes, Paul Hoverston with Air and Space Magazine. Question for maybe Bill or maybe Charlie. We had a heavy lift capability in the Saturn V. Why did we throw that away? Could we rebuild it? Is there any possibility of ever reusing that relative to the SLS?
You know, we're kind of looking at that again. I think the thing that's different this time is the modern manufacturing that's going into SLS. You know, I would say shuttle was a step away from where Saturn was with its, you know, kind of a lot of hand tooling, a lot of pretty intensive manufacturing, very labor intensive to put things together. Shuttle got better when we went to the external tank, and now we're going even a step further. We've learned what the expendable launch vehicle folks have been doing in Decatur. We've taken some of that activity and moved it down to New Orleans. We've learned from the shuttle program where there used to be 8 or 9 machines that would actually create some of the domes and the gores that go onto the tank. There's now 1 machine that does that. Where we used to have a lot of activity would be done essentially horizontally. We're now going to do vertically with the tank, and that again will ease manufacturing. So we've really kind of taken that capability that we had with Saturn, and now we figured out a way to make it affordable, that we can actually do it at these lower flight rates that we're going to see with SLS to keep us moving forward. So I think we're kind of moving off of that. You know, shuttle went a different way. You know, shuttle was seen as the way to go reusable and go with reusable components, and that would again lower cost. Now I think the right mix is somewhere between the reusability of shuttle and the expendability and the rapid manufacturing that's coming with SLS. So I think you'll start seeing some more reusability come in, especially in Orion. We'll find some components that can be used, how many times we can use the capsule. Clearly the avionics we can be used again. So we'll get that right mix. But I don't think you want to go full reusable because that carries with it a big burden. And you also don't want to be fully expendable. And so we'll work those activities out. But again, I think as a panelist told you, we're kind of going in from looking at this from kind of a business standpoint. We're looking at the environment we're in. We're looking at the budgets we've got. And it's maybe not the perfect inspirational, exciting thing we would all go do, but is this something that's sustainable over the long duration that we can actually make real demonstrable progress in a reasonable amount of time? This is what we've got.
Yeah, I think it's important to recognize what we're doing here. Bill said it in the very beginning, is its capabilities to serve multiple missions to multiple destinations, not a point solution. That's really critical. And the capability we have here is going to meet or exceed Apollo's capabilities in terms of tonnage and capability to orbit for much more affordable costs to the system. So it's being planned out with what you're thinking about in mind, what we had on Apollo, but it'll be more affordable and more capable in the long run.
Okay, we'll go to the bridge line now. I think first up is Leonard David.
Leonard David here. I heard the word conversation right at the beginning of the program, and you know, it looks like America is in the midst of a din of conversations. Not only its leadership in the world context, but also certainly how the space program fits into that. We have a probe on the way to Mars now from India. We have the Chinese ratcheting down their last bolts on a lunar lander or rover. Are we in a space race in some way? Is this a Sputnik moment revisited? What's your view on how the conversation can be ratcheted up to get people to understand how the space program fits into American leadership?
Well, David, let me try that a couple of ways. One, I have no doubts that humans will explore our solar system. The only doubt would be who's going to lead. And I think that we are who many people in the world look to lead this exploration. And I think we're getting on with it. I think that's what SLS and Orion are really all about. But at the same time, sometimes I'm a little stunned. I look at the things we're doing. I mean, we have the Curiosity on Mars. We have Maven getting ready to launch to go find out what happened to the water on Mars. We have pictures of Cassini coming back of Earth as almost just a distant star in the sky. And we have astronauts who have been on the International Space Station now for how long? How long have we been? It's, you know, over a decade, 15 years that we've continuous occupancy of humans in space. And so what's going on is actually amazing. We live in such an amazing time, and yet at the same time, you know, we're struggling with the idea of exploring and getting on with things and doing things. But we're at the beginning of a really, really wonderful journey.
Again, also I see a lot of benefit to international cooperation. You know, with Space Station, you know, this is a tremendous international activity, and there's a nice balance there. In the service module that we were able to get for Orion, that comes from Common Systems Ops costs off the space station. So again, we're seeing a nice synergy there. I think you're going to see a lot of international activity where other folks are contributing major pieces. So I'm not so sure it's a competition or a race as much how can we work together to go do these goals? Because I think when you start looking at, you know, a human class Mars mission, I don't think there's any country alone that can really support that. That's going to have to be some kind of international activity. And I would also suggest the commercial sector needs to be involved in that as well. There needs to be some other piece that plays into that moves us forward. I don't think one country will have the financial wealth nor the desire to go do those kind of things. So I think you're seeing all these exciting things happen. Then how do we put all those together? We have the International Space Exploration Coordination Group, the ISIG group, that's put together a global exploration roadmap. You know, it lays out a basic framework of how all the partners can see what they want to go do. And then some partners may be interested more in moon activities, others may be interested more in asteroids. And so then we decide we don't have to lead every one of those activities. We may let another partner lead one of these activities. We choose to lead another activity. So I think this is a unique time where we can see us, rather than kind of competing, but actually figure out how we can cooperate in a way that's meaningful and keeps us all moving forward towards the ultimate goal of moving humans out into deep space.
Yeah, I gotta agree. This is a huge job, and if the world doesn't work together, we won't get there. I think in addition, the world is looking to the United States to step out and lead that effort, and it's our responsibility to do that, to help craft the roadmap and step out as the leader so that we can all do this together.
At the recent International Astronomical Conference that we were speaking of earlier, it was amazing to see all the papers from industry from all over the world with all of the designs they are bringing forward to their agencies of all of the habitats, all of the landers, all of the different pieces that they would like to contribute. I can tell you industry worldwide is spending a lot of their own IR&D and development money to develop some of these concepts very far down the road.
And again, I would say one other thing to just think about is I don't see any other countries really moving forward with a deep exploration vehicle like the multi-purpose crew vehicle Orion. I see them all talk about starting to build heavy lift launch vehicles. They're all excited about doing that, but they don't have nearly the machinery that sits in MAF. They haven't put together barrel sections. They haven't begun starting the structural testing and analysis. So in terms of, again, this country leading in human spaceflight, again, we may not be doing the big mission per se, but we are laying that foundation behind the scenes that will eventually show us as a leader. Sometimes an athlete, right, they go to the Olympics with the torch. I'm reminded that, and you see these great events, right, but you don't see those thousands of early morning training sessions and noon training sessions and evening training sessions that went into that event. You just see the event and you go, wow, that's a really amazing athlete. I would humbly suggest that spaceflight is sometimes the same way. The amount of preparation, the amount of effort that goes behind the scenes is sometimes daunting. And then when that mission comes off and it looks flawless, everybody high-fives each other and it looks like it just occurred at that moment. But in reality, it had been worked for multiple multiple years or maybe even decades. So I think you're starting to see the underpinnings with real work moving forward towards real systems that will move humans into space, just like we described earlier today.
Okay, we'll take one more question on the bridge, and then we'll come back to the floor here. Next question is with Keith Cowing, Space Ref and Space Quarterly. Keith?
Yeah, Keith Cowing from YesWatch.com. I'm going to be the skunk from church here. When you're planning all this stuff, you clearly have to look at budgets and figure out how much this stuff costs. Can you tell me, A, what is the cost of a full-up SLS launch? 2, how do you know that it's cheaper if you don't have that cost? And third, can you give me an idea of the budget wedge that NASA is planning on for payloads for these missions?
Well, we can talk about some of it. In terms of the SLS launch, we have essentially a design to launch cost that we're trying to meet moving forward, and we've essentially looked at what kind of launch capability or cargo weight to orbit for that kind of class, and we're trying to keep it competitive with what we see on the ELV world and with the CRS world. And we can get you the exact number, but it's 500, 700 million per flight roughly, and we'll get you the exact number. But it's consistent with what we would be with the other vehicles moving forward. And again, that's a consideration. And then the other piece is you ask, where is that budget wedge that sits there for payloads? Again, we're working internationally to see who's interested in carrying some of these payloads, some of these other activities that need to be there. We're not going to do this solely as a 100% U.S. activity. We're seeing who has interest in which activities. It's almost like a company goes out and does a make-buy decision. We're stepping back and we're saying which components are so important to us that we want to build those in the U.S. We want to do those payloads here. Other areas we want to go do through an international partnership, et cetera, or there may even be some commercial interest in doing some of these activities. So we have some small line item budgets laid in place, but our first focus right now is to go lay out, do these missions we described, do the EFT-1 flight, do the EM-1 flight, the Exploration Mission 1 flight, and then the EM-2 crewed flight, and the asteroid redirect mission fits within the budgets we've got about roughly today. So again, we've got this near term laid out, and we'll lay in those other pieces as we get further down the road.
I would just add to that, Bill. I think it's real important when you compare the cost of large launch vehicles launch to smaller ones to consider the simplicity that can be put into the architecture of the system that you're designing. If you can do it with fewer launches over a shorter period of time, the vehicles are going to be less complex and the program is going to be shorter, and so the overall program cost is a big factor in addition to just the cost per pounds kinds of numbers.
If you look at both the Hubble Space Telescope and the James Webb Space Telescope, both of those had significant international content. In the case of the James Webb Space Telescope, of course, ESA is providing the launch. So it's a very significant portion of the cost of James Webb in addition to the instrumentation that they're providing. So I think in all of these large science missions going forward, we're seeing us both on the ground and in space. If you look at CERN, if you look at many of the large international collaborations which are beyond what any one country can do, when you ask about the budgets, many of these things only can be done when nations come together to do very great things.
Okay, we're going to come back to the studio. Let's get right down here on the front row.
Hi, Ledge King with Gannett. Bill, a question mainly for you, but if anybody else would like to chime in. You talked about a principal being operating under or executing under current budget situation. What happens to this program if sequestration continues into another year and possibly for the next 9 years? What's the kind of impact it might have?
Again, the thing that I need to see is what the budget results from sequestration is, right? It's not clear to me exactly how that gets calculated, how that flows down to NASA when it goes through all the great system, right? Under some scenarios, our budget may be essentially flat, where we are at the 13 enacted budget levels for the agency. In other scenarios, it may be a cut of a couple $100 million off of that, and I don't know exactly how that's going to get calculated by Congress. You know, I'm continually amazed at how the Congress can figure out new ways to calculate new numbers and provide those to us. This is one of probably my biggest challenges, not so much the level of the budget, but the uncertainty associated with the budget. You know, we essentially ran all of FY13 until we finally got our budget in August, right? And the fiscal year ended in September. You know, that's a lot of uncertainty to manage through. It's hard to tell companies how to plan for that. You know, which level, you know probably the maximum and you know the minimum, but how do you plan in that environment? It's same thing in 14. Where do we sit with 14? We're under continuing resolution, essentially at the 13 level. We're not sure what we'll get for sequester or not. And then I don't know exactly what the sequester level is. So to ask me specifically what it's going to mean in terms of impacts and expect me to give you canned numbers and impacts, I can't do that because, again, I don't know where the budget side is. The thing we're learning is, you know, again, I learned how to live and operate under continuing resolution, and then I thought I had that mastered where we could actually, continuing resolution was fine. And then we got sequester, which is, they upped the game on me. So then it became a little bit tougher to figure out how to deal with sequester, and who knows where we are next. But again, if we can build this program that's sustainable and we can make significant real progress with the funding levels we got, and it doesn't make or break or stop all activity, then we can make real progress. And that's what we're trying to do with this sustainable approach we laid out for you here.
Okay, we'll go to Jeff.
Jeff Faust, Space Review. You know, we've heard from the major aerospace companies, but there are a lot of smaller entrepreneurial companies out there, Bigelow, Blue Origin, SpaceX, and so on. What roles can they play in making this overall exploration program more affordable, more sustainable, more capable?
Again, I mean, they're playing an extremely strong role in Space Station. We're looking at how we can use them. You know, one of the things we're trying to do is set standards. You know, for example, the docking system standard, where we don't tell you how to actually design the piece of hardware. It's a standard, then it can be manufactured by anyone. When we talk about going to this distant retrograde orbit, you can probably get small tonnage to that distant retrograde orbit for resupply into that region. So if we wanted to fly potentially a habitation module there, we could use maybe SLS to get it there, then we want to resupply it. We would immediately potentially look at things like we did with Space Station with cargo resupply for that vicinity around the moon. So we're again going to leverage off the best and the most creative ideas that are out there. There's been a lot of talk on about Asteroid and essentially using the materials from Asteroid. There's 2 small companies that are looking at that, maybe more, 3 or 4 that are out there. If we can get this asteroid into this distant retrograde orbit, that's available for them to use as a practice asteroid to go look at various concepts and techniques and other pieces. There may be interest there from industry. So again, I think we're going to challenge not only, as we discussed, bringing in internationals. I think we need to challenge how we bring in the new entrepreneurial companies and find that right mix. There's a good mix of the more traditional aerospace companies, and then there's a good mix of the new entrepreneurial ones, and then there's a mix of international. And how do you put all those together to build a robust, sustainable program? And that's what we're trying to do with this activity.
Okay, we've got time for one last question. Let's go to space.com.
Thank you. Tarek Malik again from space.com, and I had a follow-up for, I think, Bill or John. You've mentioned just the flexibility of capabilities that you're building here for multiple missions, and many of our readers have been struck with what you can do with an SLS launch vehicle beyond just the initial target for asteroid redirect or Mars. And we've seen studies about a Skylab 2, giant space telescopes, and I'm wondering what types of things I read on your concept board that could either support unmanned deep space exploration or fall into a support role for manned as well. Thanks.
Jim alluded to some, and maybe Jim can follow on with a couple of those, and then John.
You know, we were talking earlier about exoplanets and all the excitement that Kepler's generated to actually, I think, change our perception of our place in the universe. People have always talked about if you could only image an Earth-like planet, if you could only see the clouds and the oceans on that planet, wow, I mean, that would be a world-changing event. Well, to do that, you need a really big telescope. You need a telescope that's something on the order of 20 or more meters in space. And we don't know how to do that today with small rockets. I mean, the James Webb Space Telescope at 6 meters is about the biggest thing we can kind of conceive of packing in a little rocket. You know, not that an Orion is a small rocket, but to get a 20 meter or 30 meter space telescope, you have to have something like an SLS. So to do these types of science projects, you really need a big rocket. But the other thing is not just the size. We talk about the cost of payloads many times because they're large. It's also the speed. Imagine that if instead of taking, as we talked about earlier, taking 12 years to get to the outer planets, you could cut that in half. Then you can have a less expensive payload because it's smaller, but the time that it takes to get there can be cut enormously, which just doubles or triples the volume of science that you can get back. So it's not always the cost of the payload, it's sometimes just the time that it takes that SLS will really speed up. And there's actually a great little book that we have here that's got a lot of the potential missions, not that we would do them all, but some of the exciting science missions that could be done with SLS that would just be inconceivable to do with a series of smaller rockets.
I think we're just beginning really to scratch the surface with the capability for a larger volume under the payload shroud, a larger mass that you can take to orbit, and a lot more propellant to propel you quickly to where you want to go are very significant. And as it becomes even more clear that SLS is runway assured relative to being developed, I think that the science community and even communities like the NRO will start to think about what kind of payloads they could develop to leverage those kind of capabilities. So we're just scratching the surface there relative to what could be done.
Think about the fact that you can put, instead of putting your complexity and cost, because cost is complexity, and how you fold something up and deploy it, that you can put that money into capability. So you can get something that's much more powerful at the same cost by using a larger launch vehicle, and as John said, a bigger shroud to put it in, so that you don't have to go through all the complexity of the origami to fold these things up.
Okay, I'm going to shake things up a little bit, and I'm going to ask a question just to wrap things up, and this is going to be for Charlie and Julie. What message do you want younger generation students today who may be the explorers of tomorrow to take from this discussion today?
Well, from my standpoint, just looking back at my own career, watching what the nation did as it embarked on Apollo, took our generation and inspired us to pursue careers that have led to a better life for the world, really, not just the U.S. And I have noticed in my business now that when we embark on a new program that's exciting, it really attracts the young generation. They come to us, what can I do in my career as I prepare in college? What should I study? How do I get prepared? How do I join your company on this new program? So I think the takeaway for them is we're providing a means to pass the baton to them and giving them the opportunity to do the kinds of things that we did, only they'll be on a much bigger scale. They can get this nation to Mars.
Well, I agree with everything Charlie said, and I'd say there's probably one other thing is, you know, the generation that's coming into the workforce now and will be coming into the workforce has been born and brought up in a different time than we were. And they, you know, have a bunch of kids that age, so I think I have some knowledge of that. They collaborate more. They're used to being a part of something more. And as we've talked about here, this is not going to be a single company. This is not going to be just the U.S. This is going to be a collaborative effort. This is going to be a, you know, to be successful, an international collaborative effort of companies and countries. And, you know, you think about that, that's like the ultimate. You know, you tell these kids, okay, you get to go work with people all over the world and you're going into space. And you're going to do things no one's ever done. I mean, that's what kids want to do, things that their parents, you know, they don't want to do what their parents did. They want to do something new. And so here you're going to go out and, you know, explore something that's never been explored and do it with people from all over the world and do it in a way that your parents didn't do it. And so I think it's like, you know, that's what, you can do, they can do. This is where we've got a lot of the groundwork there. Now we can take advantage of how they do things and how they look at life and really accomplish that. So they're critical.
Gerst, any final thoughts? Okay, great. Well, David, back to you. Thank you all very much.
So on behalf of the Tech America Space Enterprise Council, the George Marshall Institute, and the Coalition for Space Exploration, and of course, our esteemed moderator and panelists, we want to thank you for tuning in today. And I want to encourage our friends in the media, the folks tuning in on NASA TV, and our friends here in the audience to access the various media mediums that are out there, whether they're the agency and partner websites, whether it is their Facebook pages or their Twitter accounts for updates. And as NASA and Boeing and ATK, Lockheed and Aerojet Rocketdyne meet this deeper vision, bolder mission, one step at a time, we look forward to working with each and every one of you. Thank you.